Hello world, welcome to Code with Lakshit. In this video, you will gonna learn data preprocessing for machine learning. And yes, you will gonna learn each and every technique of data preprocessing which will help you boost your model accuracy more than you ever got. So yeah, stick to this video but before starting, please I'm requesting you, please subscribe my channel guys. I'm really working hard, so you can see that I have also put it a lot of playlist for you guys, so you can learn new things like real estate web scraper and all the courses that you want as a Python developer. And soon I'm going to put the React Native course too here, so make sure you hit the subscribe button. And yes, I will also teach you how you can implement machine learning in your mobile device. Please subscribe to this channel, and also please hit the like button of this video. It will really motivate me guys. So now let's see what exactly is data preprocessing. Well, data preprocessing is a data mining technique that involves transforming raw data into understandable format. So it will help your machine learning model better understand the data, and in this way your model will predict the better prediction will you ever get on your model. There are numerous data preprocessing techniques, and we will almost going to cover each and every technique which we know. And some of them are how we can handle missing data, how we can handle categorical data, how we can handle dependent variables like true, false, or male, female, and how we can split the data into training and testing data, and how we can feature scale our data. And it is not just about data preprocessing, it is about feature scaling. So guys, stick to this video. You will gonna learn a lot of thing, a lot. So it's time to start the video. But before guys, please hit the like button, please. It will really motivate me. So let's create a code cell here. And yeah, I'm using the Google Colab here. You can use any other IDE you want, like Jupyter Notebook or even Visual Studio Code. It doesn't matter. I'm using here Google Colab, or if you want any other GPU powered IDE, you can use Kaggle also. And but I am prefer using Google Colab. It is more convenient to use. So first we will import the libraries. So let's create a text cell right here, and let me name it importing libraries. So we will need NumPy here. Import NumPy as np and pandas as pd, and yeah, we need sklearn, but let's leave it for now. We will import it in the next step. So and now let's import the data right here. So for that, just click on this file icon and then upload the data. And by the way, this data, let me tell you, how you can get this data. Simply just go to github.com/Lakshit2808, and then you will be prompted to my GitHub profile. Just go to repositories and just click on this ML toolkit repository. This will be a great resource for you if you really want to learn machine learning and deep learning guys. Here you can see I have notebook for each resource that you want as a machine learner. So for for the sake of this video, just go to this data preprocessing, and here is this data file. Just you can download it from here. And the other thing is you can just click on this pencil button and copy it, and then create a new file, data.csv, and paste it right there. So it will create a CSV file for you, right? Now let's go back to the notebook. And so data file has been imported successfully. Let's see what we have right here. So you can see we have country column, age column, salary column, and purchase column. So Here you can see it is a kind of categorical data. We have France, Germany, and Spain right here. There are three categories, okay? And here we have the age data. Here you can see in the next column we have salary, and here you can note that we have one missing value, okay? And in the next one we have a purchased data, which is in whether the customer will purchase or not purchase, okay? Yes, no, yes, no, yes, no. So let me just close it and close it, and now we will just import the data right here. Importing dataset. So for that we will create a variable df, and we will use pd dot read csv function, and here I will just put data.csv. Let's see, df dot head. So we got the data right in our Python notebook. So guys, now looking at a machine learning problem, we want to predict that whether a customer will purchase the data, purchase the product or not purchase it, okay? So for that we need this purchased. We need to predict this purchase column, whether he she will buy it or not buy it, okay? So this is known as dependent variable, and the other columns are known as independent variables. So we name all these age, country, and salary as a x, as in x, and purchase in the y variable, okay? So let x equals to df dot iloc, and we need all the rows, and the column which we want are the first column, second, third, right? So we need all the columns from first one to the second last one. So this is why I have put it right here, and if I just print it, we will get these values, right? And now guys, if I put here values, it will convert it into the array, okay? So this is the right format of any data to process it, okay? Let's do the same with the dependent variable df.iloc. We need only last column, right? If I put it like this, yep. And now let's try to print it. X, Y. We got the dependent and the independent variable. Now guys, first we will start with the missing data. So by looking at our data, we can see that this salary has the missing data. So first let's see how we can find whether a data set has a missing data or not. So for that, what we can do is df dot is null dot is null. It's a function, and we have to do it in a sum. So if I do it, you can see that age column has one missing value, and salary column again has a one missing value, right? So let's see how we can handle these missing values. Handling missing values. So guys, for handling the missing values, we have a function from Sklearn library called simple imputer. So for that we need the Sklearn library. So from Sklearn dot impute module, we will import simple imputer, okay? Now let's create an instance for this function, for this class, sorry. Imputer equals to simple imputer, right? Now first it needs the argument for the missing value. So how we are donating the missing values in the data? So as you can see, we are donating it by nan. So we need to put it here as missing values equals to np dot nan, right? The other parameter that it need is the strategy, how you want to handle the missing values. So strategy strategy equals to whether you want to put here the mean of all the values, or just any random value, or the mode of any value, or the median of any value. So probably you want it to be the average of all the values. So for that I will put here mean. Now the oh, sorry for the sound, guys. There is rain outside my home, so that is why it is blasting. Okay, so where we were. So now what we have to do is imputer dot fit, and in this fit function, what you have to put it here is x. Here is the x variable, and the columns that we want to change here. I mean the column which we want to handle the missing value. So in our case it is the 0 1, it is the 1, and the other one is 2. So we want firstly all the rows of first one to the third. It will exclude the third column. So what simply it means that it will take the first column, the second column, and it will ignore the third one. Okay, and now we have to assign the value to this function. If I just print it like this, imputer dot transform x, and here we have to same put these values, right? So if I just run it, it will not assign the value to these value, it will just create a new value. So what we have to do is simply have to put x all the rows 0 to 3 equals to imputer dot transform. Now let's run it. Yeah, if I just print the x here, you will see that there is no missing value now. So we have successfully handled the missing value right here. Now let's see what kind of data we have. So we have the categorical data now. So let's see how we can handle the categorical data now. So first we will check how many values we have. So for that what we will do is we have the data frame dot country, and in this country column country we will see how many unique values we have. So for that we have a function called value count. So if I run it, okay, it's a function, I have to put it like this. So if I run it, we can see that we have 3 unique value: France, Spain, Germany. We have 4 France value, 3 Spain value, and 3 Germany value. So guys, to handle this problem, we have various functions like one hot encoder, label encoder. But the best one what I think is label encoder. Let me tell you why. So in label encoder, it is easy to get the input from the user. For example, in the case of one hot encoder, we need the vector form. Let's say 0.4 comma blah 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 blah, and let's say blah blah blah. So it it is in this form, so it will be really difficult to map this kind of line. So the alternative that we have is label encoder. What it does, it simply gives the unique number to each value that we have. For let's say it will give 1 to France, 2 to Spain, and 3 to Germany. So it will be way more easy to map the value to this function. So when the user want to enter the value, what he does is, what we can do is, we will map this value. For example, if a user press here Spain, we will automatically put the value to be 2 in the function. So it will be way more easier to map these values. So let's see how we can implement this function. So let me create here a new column. Let's say handling categorical data. Yep. Now this is again a function from scikit-learn library. So what we have to do is, from scikit-learn dot preprocessing module, we want to import label encoder. Label encoder. Okay, label encoder. Yep. Now we have to create instance for this class. Label le equals to label encoder. Now guys, let's say which value we have to change. So we have the value in the 0th column, so we have to transform this value. So for that, what we can do is, x0 equals to li dot fit transform, and here we can put x0 again. So if I run it, let's see, we got the error right here. Okay, label encoder is not defined. I know I have to put here in the capital. L should be capital right here. So now again run it, again the error. Wow, I love these kind of errors. So it need argument must be string or number. Okay guys, let me show you what exactly is error. So if I put here x0 and run it, so you can see that we got this value and we don't want this. So what exactly we can do here is, so if we put it all the values and comma and then give the 0 value and run it, it will probably give the all the countries that we have in our data. So the first value here refers to the column which we want, I mean how many values that we want in the row, and here refers to the column. So we want all the values from the first column. So here you can see that we got that value. So instead of putting here 0, what we can do is, we can put it like this, and if I again run it, hopefully we don't get any error now. Let's see. Okay, it runs fine. Now if I print it, print x, so all the values has been successfully been encoded. Now guys, let's see how we can do the mapping of these values. I mean how we can say that, let's say 0 belongs to the first, 0 belongs to the France, Spain, and Germany. So if the data is too long, let's say we have like thousands of countries, we cannot do like this, 0 equals to France, 2 equals to Spain. So this cannot be the best approach. So what exactly we can do here is, let's create a variable here, country, which will be equals to df, and df dot country, country, country dot values, right? If I run it, Okay, COUNTRY. It is not counter, it is country. If I do it like this and print it right here, we got all the countries row wise in the country variable, right? Now guys, what we have to do is we have to create a dictionary out of these values, right? So for that, data dictionary, let's create a variable data dictionary, which will be equals to dect. It's a function from Python which is inbuilt, right? And inside it we want to zip, we want to combine two variables, which is gender, not the gender, it's the country, right? Country, and the other one is x comma 0, right? These are all the values that we want. If I just run it, let's see what exactly happens. Now let's print it. So boom, we got all the values for each country name, right? So this is how we do the mapping of the categorical data. Now guys, if I do it like this, data dictionary dot get, and here I pass just the, let's say, country name France. Let's see what will be the output. We got the 0. It belongs to the 0. So this is how we do the right mapping. I think this is the only reason it is better. It is better from the one hot encoder, and I prefer to use it in my most of the projects. So we are done with the categorical data. Now let's see what exactly we have. The other data that we have is the purchased, whether the person will purchase or not purchase. So it is present in the y, and it is also the dependent variable. So let's see how we can handle it. I can also give you as a task right now. Just pause the video and try it yourself. I have already taught you. You can do this with the label encoder. So 1, 2, 3. Now it's my turn. I will do it. From, let's just give the heading first right here. Let's say 0, 1, or what else we can say it. Yep, encoding dependent variable. Let me tell you that it is useful when you have a data like gender data like male or female. So it will be better to use this label encoder right here. So what exactly we will do is from scikit-learn dot preprocessing, we will import label encoder again, encoder, and we will again create the instance for this, which will label encoder, and this time we want to change the y value, so it will be y dot fit transform y. So if I run it, hope we don't encounter any kind of error now. Yep, successfully executed. And now let's see what is stored in the y variable. Boom, we got the encoded data for the y variable. Now I'm giving you 5 seconds, I mean just pause this video and try it yourself how you can map the dependent variable into the yes or no strings. Ready with the solution? No, don't worry, I will do it for you. Df dot, what we have, purchase, let's name it first prediction equals to prediction, let's say prediction data, it will sound much better. Prediction data equals to df dot purchased dot It's a purchase, right? Yep. Let me just copy it. Purchased dot values, and if I run it, prediction dot data, and let's see what exactly the output will be. Yeah, we got the binary output right here. I mean yes or no. So now let's do the categorization for this. Categorical prediction equals to dect zip, oh my god, zip, and in the zip what we have to pass? Yes, the prediction data, and the other thing is the y variable. Let's see what we get. Okay, we got the error. I love it. Prediction data is not defined. Don't worry, I will just copy it and paste it right here. Let's see what we get now. Nothing. Now just run it. Boom boom shaka shaka. We got the mapped data right here in the cat predict variable. So again, if we do it like this, cat predict dot get, and if the user enters no as the input, and if we run it, we get the 0 as the output. Let's see. Yep, I'm right. So guys, let's see. Till now we have imported the libraries, imported the dataset, handled the missing values, handled the categorical data, and we have seen how we can handle the independent variables or the binary variables. Now guys, it's time to see how we can divide the data into training and testing data. So for that, let's create a new section right here. Let's name it train test split, right? And again, to perform this task, we need our DRS library scikit-learn. So from scikit-learn dot model selection, we will import train test split. Yep. Now let's declare 4 variables: x train, y train, x test, y test. So x train, x test, y train, y test. So we have to put here train and test function right here, train test split. Yep. Now we have to pass here the values that we want to pass here. In our case, the independent variable, which is x, and the dependent variable, which is y. And now in the next step, we have to put here test size. I mean, how many percent of the data you want as a test data. Let's say 20% of the data we want as a test data. So for that, we need to write it in the probability format, which is 0.2. And now we have to put here random state. So let the random state equals to 1. And now if we just run this cell, let's see what will be the output. Probably no error. Yep, no error. If I just see what is there in x train, x test, y train, y test. So we got the x train as these value, x test as these value, y train as these value, and y test as these two values. So we total have the 10 variables, 10 values in the data. So we got the 8 values in this text train and 2 values in x test, and similarly we got these values in the y variable in y train and y test. So guys, we have imported the libraries, we have imported the dataset, we have handled the missing values, we have handled the categorical data, we have handled the binary variables, we have created the train test split. So what is next? So we need to see what feature scaling is, how it can help the model to boost their productivity. And by productivity I simply means the accuracy, right? So guys, let's first discuss what feature scaling is. So feature scaling is a method to use to normalize the range of independent variables or features of data. So what exactly I mean is, let's say you have a data which has a value up to trillions or billions. For let's say you have a data like this. So it will take a lot of time for your machine learning model to process it. So what feature scaling does is it normalizes it. By normalizing it, it means that it takes the value into certain range. Let's say 0 to 1 or 1 to 10 or whatever the value it want. It depends on the function to function. So there are mainly two kind of feature scaling methods. The first is normalization and the other one is standardization. So let's see what is the difference between these two values. In normalization, the scale of range is 0 to 1, or sometimes it goes to -1 to 1. So in normalization the value goes from 0 to 1 or -1 to 1, and the formula for it is something like this. The new x value which we get after the normalization will be equal to x and minus the lowest value which we have in the x column and the maximum value in the x and the minimum value in x. So after computing this we got the normalization for the independent variable. So let's see what is standardization. So firstly, standardization does not bound to any certain range, and the other thing is the formula for standardization is the new value will be equals to the value of x minus the mean value of the x divided by the standard deviation. If you know, if you are well proficient with the maths, you will know what is standard deviation, how we can calculate the mean, and so you don't have to worry much about these things, but at least you should know them. These all the computation and the all the formalization will be done by the scikit-learn functions, so you need not have to worry. So the other question which arises after learning these two functions, normalization and standardization, is which one should we use? So based on my research and other people who have implemented these kind of feature scaling techniques, has come to an output that standardization works much better than normalization. So I myself prefer using standardization more rather than normalization. So in this video, we are going to learn how we can implement the standardization in the machine learning model for getting the best data for the machine learning model. So for that, we again need our dearest library, scikit-learn. So from scikit-learn.preprocessing module, we will import standard scalar, and let's make it instance of it, standard. Let me just copy it and paste it right here, and we have created the instance successfully. After creating the instance, what you have to do is you have to select the values which we want to feature scale. So in our case, there are the age column and the salary column which we have to feature scale, this one is the categorical value, so we have to do nothing with it. So we have x train equals to all the rows, and we want it to be 0 1 1 2 everything, and it will be sc dot fit transform. Again, just copy it and paste inside here, and let's do the same with the x test. And point to be noted here is that the feature scaling is only applied to the independent variable. So I have already told you this, but please remember that feature scale is only applied to the independent variable. You cannot do the feature scaling on the independent variable. If your data, if you have to predict the salary, just remove it. You have nothing to do with the feature scaling in the dependent variable. So let's do it with the x train, x test, sorry. There are same columns in the x test too, so we will do like this. Just copy it and sc dot fit transform x test. Now just run it, and if I just print x train and x test, boom, you can see that we had the normalized value, which is probably in between -2 to +2, I think that. And yeah, we have applied the standardization, so the value is not bounded to any particular range, but still we got value very lower than we expected. And guys, if you're still watching this video, it means that there is something I have provided you. Please hit the like button and subscribe to my channel. It will really motivate me a lot. So let's see what we have covered. So we have imported the libraries, we have imported the dataset, we have handled the missing values, we have handled the categorical data values, and we have encoded the binary values, we have splitted the data into training and test, and lastly we have seen what is feature scaling and how we can implement it. So these are all the major things which you have to do to make your model predict the best possible values. So you can try it on your own data set and check what values are improved in your machine learning model. And yes guys, if you need the whole implementation of this code, just simply go to github.com/Lakshit and then search for my ML toolkit repository, and in this just go to the data pre-processing folder, and here you will get the file which contains the whole implementation which I just did. So that's all for this video guys. Thank you for watching and hope you have learned something from this video. Thanks.